Okay, so this is Algebra 1, Lesson 45. We're continuing with systems of elimination, or solving systems by elimination. Remember systems of lines. We're dealing with just lines, but when two graphs come together, the answer is where the lines cross, right? So what should your answer be? A what?
Intersecting point.
Intersecting point, it's called a what?
Coordinate thing.
Coordinate plane.
Not a coordinate plane, it's called an ordered pair. What's it called, everyone?
Ordered pair.
Good, so you should have two answers, an X and a Y, right? And so, instead of us graphing, we do this thing, we solve by elimination so that you don't have to do as much graphing. It's a lot easier and more accurate instead of graphing. And so, we can eliminate, and so we have to figure out which one we're going to do. X's or Y's, and we're trying to find the same number, right? We could either find two of the same number or two of the opposite number, right? So let's say I had a 4 and a 4x and 4x. What operation would I use to get rid of 4x and 4x?
Subtraction.
Do you agree with Marky?
Sick. Thanks, Adam.
Let's see. Equation 1 is 4x. Equation 2 is 4x. What operation would you use again?
Subtraction.
Good. Equation 1, let's pretend it's positive 4x. Equation 2 is negative 4x. What operation would you use to eliminate the x's?
Subtraction.
Subtraction, right? You following me?
Yeah.
Okay. And then yesterday we dealt with equations that were different, right? Where they weren't perfect. So let's say equation 1 had 2x and equation 2 had 4x. What would you do to eliminate the x's? What would you do?
Division.
Multiply by which one? Equation 1 or equation 2? Equation 1. But what happens? Sometimes we could divide by
2.
which one would you divide by 2? Equation
2.
Good. You could do that as well. Okay? Does that make sense, everyone?
Yeah.
But let's say today we have a bigger problem. Let's say none of the variables work. You can't multiply it out. Let's say equation 1, it says 2x, and equation 2 says 5x.
You have to.
Predict with your neighbor really quick what you could do. If equation 1 says 2x and equation 2 says 5x, what would you do? Go. You might have to multiply one or both. I don't know. Take a moment. Predict with your neighbor. Make a plan. Okay.
Get like 5.
So, we're making predictions. So, predictions sometimes aren't right. Let's see if you're right. Raise your hand if you want to make a prediction on how to deal with this. Yes.
You find the greatest common factor? Or what is it?
Least common multiple. Uh-huh. And what does that mean? We got 2x and 5x. What would you end up doing?
So you would put parentheses on both equations, like for 2 it'd be 5 and for 5 it'd be 2, which would make
You would
10x.
do what? Multiply, divide? What would you do with
You
2?
would multiply them.
Ah, good. Do you agree with him?
Yeah.
Yeah. Exactly. Okay, so that's the concept today. So it's really not that much harder. Okay, so if you're in the video, these are the steps for today. Or is it right here? Same as before. So I'm just going to move on from that. Okay, so number 1. We have 4x minus 3y is equal to negative 6. All over 3x, or the second equation is 3x minus 8y is equal to negative 16. So I'm noticing that my my x's are lined, y's are lined up, equal signs are lined up, constants are lined up. So I always like, numbering my equations so that I know what they are. But I'm noticing, can I multiply anything with 4 to get 3? No. 3, anything to get 4? No. Can I multiply 3 with anything to get 8? No. 8 times what is 3? No. I can't do anything because it's kind of like they're all different. So I need to pick a variable to eliminate. X's or Y's, okay? So the first thing you need to do is pick a variable. So I'm going to pick the x's because I know that 3 times 4x is 12x, right? So I put parentheses around the first equation. And on the second equation, I'm going to multiply 3x times 4 to get 12x. And then I should have 12x and 12x. And I know I can eliminate it, right? So first equation, I'm going to multiply by 3. And I'm going to call this new equation equation 3 because it's a new equation, okay? So 3 times 4x is 12x. Negative 3y times 3 is negative 9y. Bring down an equal sign. Negative 6 times 3 is negative 18. Okay? That's the new equation 1, which we'll call equation 3. Okay? We did that yesterday. Now we're going to do it again. Equation 4. Put parentheses around it. and we're going to multiply it by 4 because I want it to be 12x, right? So 4 times 3x is 12x. 4 times negative 8 is negative 32y. Bring that an equal sign. Negative 16 times 4 is negative 64. Okay? Now we're going to put parentheses around the second equation. And we want to figure out what do I need to do to get rid of these x's. I'm going to put a subtraction sign because I know 12x minus 12x eliminates the x's. Now I know I did it correctly. Now the numbers get bigger and it's a little bit more difficult. So now we got negative 9y minus negative 32y. Well, when we subtract a negative, it's like I'm adding, so it's like negative 9 plus 32, which is positive 23y. And then we got the equal sign, bringing that down, negative 18 minus negative 64. We're going to add 64 to negative 18, which is going to be positive 46. Divides both sides by 23, and you get y is equal to 2. Okay, that's the answer for one of the parts of the ordered pair, so I'm going to just write that down to the side so I don't forget to do it later. And then I need to plug it back in. I could plug in y to whichever equation I want. 1, 2, or 3, or 4. Okay? So 1, 2, 3, or 4. Which one do I want to pick? I always pick the smallest number. So which ones are the smallest to you? 1, 2, 3, or 4?
1.
1. Okay, good. So I'm going to put it back into 1. And I'm going to rewrite 1. But instead of writing y, I'm going to substitute 2 in there. Okay? Then I just do what I did earlier this week. You got to multiply it out. We got 4x minus 6 is equal to negative 6. Add 6 to both sides, so x is equal to, or 4x is equal to 0, divided both sides by 4, so x is equal to 0. Okay, that's number 1. Alright, questions on number 1. Okay. Number 2. Number 2, is it, I'm looking at number 2 and I'm looking, hey, is it all lined up? No. Okay, so I'm going to, on number 2, I'm going to rewrite the equations, but I want to make sure I name them so I don't get confused, okay? So on number 2, it starts with constants on the first equation, right? So there's 12. Are there any other constants here? No. So I'm going to bring down 12. Okay?
Would that be equation 3?
No, this is the same equation, still equation 1. We're not multiplying, so we're not making new equations. We're just organizing our equations, okay? Good question. Is it equation 3? No, it's not. Okay? So, equation 1 we're bringing down, 12, and then I ask myself, is there constants on equation 2 next to it? Yes, there's a 0, but are there any other constants on equation 2?
Yeah.
Yeah, what else is there? 36. Is it on the same side as the 0?
No.
No, so how do I move positive 36 over to the left-hand side?
Subtract 36 from both sides.
Okay, good. So what's 0 minus 36?
Negative 36.
Good. Okay, so we're going to bring down the equal signs now because equation 1 and equation 2 have equal signs there. Okay? Equation 1 has a 4x here. Does equation 2 have a x underneath it? Yeah, they're all together. So we're just going to bring down negative 12x. Okay? Equation 1 again, it says plus 3y. And then equation 2, it says plus 14y. So cool. That wasn't too hard, right?
No.
Now they're organized, right? Looking at here, can I get rid of my x's or y's? Well, I'm looking at my x's here.
Yeah, you can get rid of those.
I could get rid of my x's easily just by multiplying this first equation. So this is now just like yesterday. So problem number 2 is about you organizing it and then figuring out, oh, look, I could just multiply 1. So you don't always have to multiply both. So on equation 1, I'm going to multiply by 3 because I know that 4x times 3 is 12x. Okay, you see that? And we want 12x and 12x to be the opposite so I could get rid of them. So we're going to combine. Oh, sorry about that. We're going to combine both of these, okay? And I know I want to get rid of the x's, so I'm going to use the addition sign. The 12x's cancel out. Negative 36 plus 36 is 0. Bring down the equal sign. And then we have 14y plus 9y is 23y. When we solve for y, we get 0 is equal to y. Use this symmetric property, y is equal to 0. Then you plug it back in just like the last few days, and you get x is equal to 3. I picked equation 1. Why did I pick equation 1?
Because it's smallest numbers.
Smallest numbers. Okay. You guys good? Raise your hand if you're tired and sleepy. Okay, I know, it's rainy. Okay, so I like it when you guys talk. So let's have one solid twos about number 1. Remember, we're emphasizing ones are telling the twos about how we have to multiply both of them. Okay? Twos then will talk about how we had to rearrange these problems a little bit and then multiply one of them. Okay? Well, when I hear you talk, that'll wake you up a little bit. And it's really good to talk about it because it's good practice to think about what we're learning. Okay? Ready? Set. Number 3. What answers?
No.
In the corner.
No, there's no answers. Yeah.
Clearly the system doesn't work. Don't do the system. It doesn't work.
E4 isn't there.
E4?
Yeah.
So number 3, let's name the equations. Okay? We got negative 9x minus 2y is equal to negative 9 and 6x minus 3y is equal to 6. Do you want to make a strategy with your neighbor? Let's figure out a strategy. X's or Y's. Turn to your neighbor and figure out a strategy. And what would you do?
Why? No. No. You do Y's? Yeah.
Okay, so what are our strategies? Can we get rid of the X's or the Y's? Y's, okay? Does it matter?
No, not really.
It doesn't really matter, okay? For the sake of this example, I'm going to get rid of the X's, okay? Now, the lowest common multiple for the X's is actually 18, okay? But what if you make a mistake and you go bigger? Does it matter? No. Let's just try it out for the sake of trying it out. We're going to go larger here. I'm going to multiply. I'm going to get rid of the X's. Let's say I thought I had to multiply by 4. So I'm going to multiply negative 9 times 4 and 6 times 6 to get 36 because I'm thinking, okay, those are the LCMs, right? So I'm going to multiply it out. So negative 9x times 4 is negative 36. Hopefully you're all working along with me, right? Not staring off the space, okay? And we got negative 8y is equal to negative 36. Equation 4. Can you tell me what equation 4 is for me, please? Okay.
Minus 18y
18Y.
Okay.
equals 36.
Good. Okay. Let's put parentheses around equation 4. Turn to your neighbor. Tell him what operation you would use to get rid of the x's. Subtraction or addition? I heard 2 answers.
I'm just playing.
Well, let's think. What happens if I put subtraction in? Negative 36 minus 36 is? Negative 72. Is that really getting rid of it?
No,
Eliminating
sir.
it? No. So we're going to have to add, okay? So, hey kids. You got negative 8 plus negative 18y is negative 26y. What's negative 36 plus 36? 0. Okay? Finish up my problem for me. I want you to give me the ordered pair of the answer. Ready? Set. Go. So that's the answer for number 3. Let's jump to number 5. Okay? Number 5. Erase your boards. Let's start again. We got 0 is equal to 3x minus 6 minus 3y is equal to... and then we got the second equation as 0 is equal to 8y plus 25 minus 5x. So is anything organized here? Yes or no? No, it's not. So we're kind of in a little bit of trouble here. So now we need to figure out what to do. So let's start up here. Let's start by naming our equations. And let's start with our constants here. Okay, there's a 0 here. Okay. Are there any other constants on equation 1 that need to come to the left side? The constants are here. Are there any other constants on equation 1 right now? Good. So there's negative 6 right here. Is this negative 6 with a 0? No. So how do we get the negative 6 over to the left side of the equal sign? Good. So what's 0 plus 6? Good. 6, right? Okay. Then we're going to bring down an equal sign because that's what's next. Okay. Now look here. We got 3x. Are there any other x's on the first equation? No, so let's just bring 3x down here. Okay. There's a negative 6 here. Should I bring that down? Yes or no?
No,
No, why not?
because you brought it over to the other side.
Oh, that's right. I have to remember I brought it over, so I'm going to ignore that. And then there's minus 3y. Are there any other y's on the first equation?
Nah.
Nope. Okay. So I just organized that. Now we need to make sure equation 2 looks like this. Okay. Are there constants on equation 2 in the right place? Are they first? Yeah, they're first. But are there any other constants on equation 2? No.
Oh yeah, 25.
Good. So the 25, is it with the 0 on the left side of the equal sign?
No. You gotta subtract it over.
Good. So with 0 minus 25?
Negative 25.
Good, okay. Hey kids, there's only so much I could do. You gotta put the effort in. Some of you are just sitting there, okay? So we have to subtract 25 on both sides. Okay? Then we have to bring down the negative 5x because it's on the, we want the x's to come together next because we started x's here. And then of course there's positive 8y's. Okay? Okay, finish up the problem for me, please. Ready? Set, go. Negative 3, negative 5, okay? That's it. Alright, that concludes our lesson.